Hey, what's up, Algebra 2 students? This is Mr. Shack, and this is your Module 7 review video, okay? So, I believe on this one, just looking through it, I believe I'm going to be able to get to all of them, but the only way that's happening is if I go very fast, so please, remember, there's no way you're understanding everything I'm saying if you are just watching this all the way through, not pausing, not trying these on your own, and really, you're just not going to be able to listen completely and comprehend what I'm saying at the speed I'm going, because if I'm going to fit this all in my 30 minutes, because I don't pay for the premium video recording thingy, so we just got to make sure that I get through this, and you need to make sure that you are not just trying to rapidly copy down everything that I am writing, because you're not going to learn anything. That does absolutely nothing for you to just copy all this down. Okay, so please make sure that you aren't just copying down. You're trying things on your own and then watching where you got stuck, or watching to check your answers, check your process, see where you went wrong, maybe stuff like that. Okay, you shouldn't just be watching this through, copying everything down that I'm writing. You should be trying these on your own, practicing, using this as a guide to get you unstuck, and then continue through the problem, continue to check it with this video. Okay, enough of that. Like I said, I got 30 minutes, so I got to hurry. All right, so first one, we have, what is the solution to the equation 80 minus 10x equals x minus 12? Okay, well, if we're going to solve this, we want to get rid of this square root. And how do you do that? Well, you need to square it. That's what gets that to cancel. And what I do to one side, I absolutely always got to do to the other. So that leaves me with just 80 minus 10x here, because the root and the exponent of 2 cancel each other. And then I have x minus 12 squared over here. But x minus 12 squared, well, that means x minus 12 times x minus 12. So I got to FOIL that out. So let's do that. X times x is x squared. Okay, that's this. Negative 12x, or negative 12 times x is negative 12x. Then this x times negative 12 is another negative 12x. Whoa, one too many ones there. Okay, and then lastly, we have our negative 12 times negative 12. That's positive 144. Now, this is the FOIL method that I used. You could put it on the box where you have x minus 12 on the top, x minus 12, you can't see what I'm writing, x minus 12 on the side, and multiply it out like that, combine your like terms. Here are like terms, negative 12x and negative 12x. Well, that makes x squared minus 24x when you combine those two, plus 144. And remember, that was equal to this, 80 minus 10x. Okay, so now if I'm going to solve this, we have an x squared, so this is a quadratic now that I have to solve. So I need to get everything onto one side so that it's set equal to 0. So I'm going to add 10x to both sides, and then I'm also going to have to subtract 80 from both sides, because that's what, now those cancel and those cancel. Okay, and when I do this, well, negative 24, so nothing's happening with the x squared. Negative 24x plus 10x is negative 14x. 144 minus 80, that is 64. Okay, and now that is set equal to 0 like we wanted, right? Because everything on this side canceled. Okay, and now to solve something like this, we could try to factor. Pause, try to factor. Okay, unpause. Hopefully you tried actually doing that. You'll see you can't factor it. So then I always go to the quadratic formula then, because the quadratic formula helps us solve any quadratic equation. So we have negative b, well, b is negative 14, plus or minus the square root of b squared, negative 14 squared, minus 4 times a, which is 1, so it's 1x squared. So remember, our a is before our x squared, our b is before our x, our c is our constant. So minus 4a is 1, c is 64, and then this is going to be all over 2a, all of this. 2a, well, a is 1, so 2 times 1. Okay, so now I'm going to start by simplifying my discriminant, everything inside of my radical. Negative 14 squared, that's 196. And again, I'm just doing this in my calculator. So I end up with 196 Okay, I'm running out of room fast here. That's okay. 196 minus 4 times 1, well, that's just 4, times 64, again, doing it in my calculator, and that's 256. So look what your discriminant becomes. Okay, 196 minus 256, well, that's a negative number. You can't take a square root of a negative without it being imaginary, and for the sake of this, we say no real solutions. Okay, and that is how you would tackle a problem like number 1, no real solutions. Okay, moving down to 2, if it's finding the inverse, okay, don't worry about too much that says when x is greater than or equal to 1. Just go ahead and start solving the inverse for this here. So we have y equals x plus 1 cubed minus 4. Well, I always just start by switching my x and my y. And that's literally all I did. I just switched my x and y and rewrote it. And now I am solving for y here. So first thing I got to do is I got to add 4 to both sides. I get x plus 4 equals y plus 1 cubed, because these go away. Then if I'm going to get rid of this cubed here, I have to cube root both sides, and I hope you're not just copying down everything I'm writing. Try this on your own, please, and then make sure you're checking it with me. That's going to be y plus 1, because these cancel each other. And what I do to one side, I got to do to the other, so I got to cube root the other side. So we get y plus 1 equals the cube root of x plus 4. Okay. Then lastly, to get y alone here, I just have to subtract 1 from both sides, and I get y equals the cube root of x plus 4, and then we had to subtract 1 on the back end. Okay, and really, this is the inverse of y now. Okay, so that's your answer there. Okay, moving on down. These next these next 6, these next 4, I'm going to go very fast because they're short. Okay, so how is the function cube root of 5x transformed from its parent function? Well, we have a 5x inside, and remember, we think of anything inside or like going along with x or inside the root, it's 1 over b x. Okay, well, it can't be 1 over 5 because that's 1/5, but 1 over 1/5, that's 5. So b here is 1/5. And what this is going to do, that's going to horizontally compress. Okay, it's horizontal because it's in the root with x, and it's going to compress because it's a fraction. Okay, now here, kind of the opposite. We know it's 1 over b root x in our root, 1 over bx. Okay, so, well, 1 over b, well, that means b is just the 6. So b is 6 here, and that is going to, again, it's horizontal because it's in the root, and this time it's going to stretch it because b is greater than 1. Okay, now here we have a 4 outside, so that's like if our a was equal to 4. It's a multiplier still, so multiplier just out front of our root, and when it's out front like that, multiplying by it, that's going to be a vertical something, and if it's greater than 1, it's a vertical stretch. And now down here, we have an a equals 1/2. It's between 0 and 1. Again, it's still going to be vertical because it's out front, but this time it's going to be a compression, vertical compression. Okay, moving on to number 7, we have what is the solution to the equation, blah, 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 blah. Okay, starting this off, we need to add 17 to both sides. Just trying to get everything away from x. This looks scary, but it's really not, as long as you know your rules for solving equations, which we all should by now. Okay, because when I add 17 to both sides, that gets rid of that on this side. 31 plus 17 equals 48. Okay. Then next thing I got to do, I need to get rid of this 12 out front. And that's saying 12 times all of this junk, so I need to divide both sides by 12. When I do that, that gets rid of the 12. That was my goal. So I'm going to rewrite it over here now. On my left, I just have the cube root of 54 plus 2x. And that equals 48 divided by 12 is 4. Okay, next thing I got to do, I got to get rid of my cube root. So I am going to cube both sides because that's the opposite of cube rooting. What I do to one side, I got to do to the other. Now the root and cube cancel, so I am left with just 54 plus 2x on my left. 4 cubed is 64. Okay, then I got to subtract 54 from both sides. This now looks like an equation that is not scary at all because I am left with now just 2x equals 64 minus 54. That is 10. Lastly, I got to divide both sides by 2. That gets my x alone because these cancel. 10 divided by 2 is 5. So we get x equals 5 here. All right, going on down to now we have a word problem. It's a rectangular piece of wallpaper that is 31 inches long by 17 inches wide. Okay, and the length and width of the wallpaper are each reduced by the same amount. So it was 31 by 17. That's 31 times 17, but they're both being reduced. We don't know by what, but it's by the same amount each. So instead of it being 31 by 17, it's 31 minus x by 17 minus x, because they're both being reduced by the same amount. And it has an area of 176 square inches. So we set it equal to 176. Now from here, well, we have to FOIL this out, and if you want to FOIL or put it on your box, either way, first, 31 times 17, you just put it in your calculator, you get 527. Negative x times 17, that's negative 17x. Okay. And then 31 times negative x, well, that's negative 31x. And then negative x times negative x, well, negative times a negative makes a positive, and x times x is x squared. Again, this all equals 176. I need to now combine my like terms, negative 17x and negative 31x. That makes a negative 48x plus x squared. Okay, and we still have this 527 out front equals 176. But again, if I'm going to solve this type of equation, solving in a quadratic equation, we need to get it set equal to 0. So I want to get this 176 out of here. That's what's going to make my right side equal 0. What I do to one side, I got to do to the other. This is my like term to go with 176. So 527 minus 176 is 351. And I am actually, well, yeah, I'm actually going to write it over here. 351, because now I'm just kind of changing it into standard form. That's this. I just moved it out over here. Negative 48x, and then x squared. And really, I just reordered this. That's all I did. Okay, plus a negative 48x. Well, plus a negative 48x, that's just minus 48x, so I don't know why I wrote it like that. Okay, and then again, 176 minus 176, that's equal to 0. So now we have a quadratic equation that we can solve. And I sure as heck do not want to try factoring this if I'm trying to think of something that multiplies to 351 and adds to negative 48. That's getting to be way too big of numbers. So I'm just plugging this in my quadratic formula, knowing that a equals 1, because that's in front of my x squared. My b is negative 48, because that's in front of my x. And my c is 351, because that is my constant. Again, I'm going fast. I'm really going to go through this quadratic formula fast. See if you can do the quadratic formula. You are given the quadratic formula, so just know how to use it. Okay, negative b, that's the opposite of negative 48, so I'm just going to write 48 plus or minus the square root. Again, I'm going to go fast, of negative 48 squared minus 4 times my a is 1 times my c is 351 all over 2a. Well, a is 1, so it's just 2. Okay, negative 48 squared. I'm actually going to do all this. 48 squared. Okay, that's 2304. Okay, and then that's minus 4 times 1. Well, 4 times 1 is just 4. So minus 4 times 351. You can just put it in your calculator like that. And you get 900. So really, what we have is 48 plus or minus the square root of 900 all over 2. Okay, I put square root of 900 in my calculator. That is 30. So I get 48 plus or minus 30 over 2. Okay, Then from there, I'm saying, okay, well, 48 plus 30, that's 78. 78 divided by 2, actually, I'm just going to go to x equals. 78 divided by 2 is 39. And then I do 48 minus 30. Well, that's 18. 18 divided by 2 is 9. So these are the two solutions I get. But look, if I did 31 minus 39, well, that would be a negative piece of wallpaper, which that doesn't make sense. So it can't be 39. 31 minus 9, yeah, that makes sense. 17 minus 9, that makes sense also. So my solution is 9. Okay, if you left it as x equals 39 or 9, it would be hard to take points off. But just think about the situation. Well, you can't have a negative piece of wallpaper. 17 minus 39 is also negative. You can't have a negative piece of wallpaper. So your correct solution is 9. All right, moving on to number 5, and I don't know how I'm doing on time, but I probably got to pick up the pace even more if I'm going to fit this in. I think I'm probably like halfway through time-wise. I probably got about 15 minutes to finish this up, so let's keep it moving. It is asking, what is the average rate of change of f of x over the x interval 27? So this is when x equals 27. So we have when x equals 27, we got to try to find what y is going to be. And then when x equals 64, we got to try to find what y is going to be. Okay, whoa, a staple got in my way there, so I couldn't make my parenthesis, and it's still getting in my way. Try to make that, wow, okay, that's annoying, but that's okay. All right, so when x is 27, I just plug it in there. Cube root of 27, if you don't know it, you do it in your calculator. 27 to the 1/3, well, that's 3. 4 times 3, that's 12. 12 plus 3 is 15, so I get 15 for my f of x. Well, f of x is just a fancy way of saying y. Okay, I get 15 for my y when my x is 27. If you just had me do that one for you, pause, do this one, and then you can check it with me. Okay, now I plug in 64 for my x. Cube root of 64 is 4. 4 times 4 is 16. 16 plus 3 is 19. So now these are my two ordered pairs, and how do you find the average rate of change between two ordered pairs? Well, it's just like finding slope between two coordinates, y2 minus y1 over x2 minus x1. Okay, x, y, we'll call this x2, y2. Okay, so you should be able to plug this in. Go ahead and do that. Now I will do it, and again, I'm expecting that you are not just copying everything down. You are pausing, trying these things on your own. You're not going to be learning a whole lot by just copying everything down. So I'm just going to continue to remind you throughout this video. y2 minus y1, 19 minus 15, over x2 minus x1, 64 minus 27. 19 minus 15 is 4. 64 minus 27 is 37. Can't reduce that a whole lot. I would leave it at, or you can't reduce that at all, so you leave it at 4 over 37. That's your average rate of change. Let's keep moving. Okay, consider the graph number 10. We have f of x equals the cube root of x, okay, but it's been transformed a little bit, and we can figure out the transformation just by looking at the vertex, okay, and the vertex is at 3 comma negative 2, and remember what the vertex is. It is h comma k. Okay, so then we just need to go to our cube root function, and we have to know where h goes and where k goes. H, it's always x minus h in our root. Well, h is 3, right? So we have x minus 3, and then outside is our k. It's plus k, but it's a negative 2, so it's actually either plus a negative 2, or you can just say minus 2. That is your function. Okay, let's keep moving. We are given f defined by these ordered pairs, and f inverse represents its inverse, or f inverse represents its inverse, f to the negative 1. That's how you read that, f inverse. Okay, place an x in the table to show whether each statement is true or false. Well, then I'm going on here, and I have the domain of f is, well, it's all the x values. Here's f, all the x values, negative 8, negative 7, negative 1, 3, and 11. Yeah, that's exactly what they list, so that is true. Now the range is all the y values. So we have 4, 2, okay, that's the first two. Then we have 9, yep, it covers that. 4 again, well, we already covered that. And 5, yep, so it listed them all, also, all my y values. Okay, domain of f inverse, remember the domain of the inverse is going to be the range of the original, so these kind of go together. And 2, 4, 5, 9, 2, 4, 5, 9. Yeah, true. Okay. Because this one was true, I can just go off of this. Yeah, 2, 4, 5, 9. Domain of F inverse should always match with the range of your original. Okay, now the range of F inverse, that should match with the domain of F. This one was true, so we can just look at this. -8, -7, -1, 3, 11. -8, -7, -1. Ooh, they skip a 3 and then 11. Since it skips one, this is false. And the relationship of F is 1 to 1. What that means is that for every x, there is exactly one y, and for every y, there is one x. Okay? -8, 4, -7, 2, -1, 9, and then we have 3, 4 again. So we see how there is 4 goes with 2 of the x's, so it is not 1 to 1. Okay? Consider the function 3 times the square root of x minus 7. Place an x in the table to show whether each statement is true or false. Well, the inverse of g of x is a function. Let's find it real quick. Go ahead, pause, find the inverse. It's good practice. Okay, and what you do to start that is you just change your x and y. Remember, g of x is just your y. So you have 3 root y minus 7. Okay, I start solving for this, I'd have to add 7 to both sides. I get x plus 7 equals 3 root y, because these go away. Then I have to divide both sides by 3, so I get x plus 7 divided by 3 equals, well, these cancel now, so it's just root y. Then I have to square both sides. What I do to one, I got to do to everything on the other. So I get y, but remember, y is just my inverse of x. Since we're done, I'm just going to write it as that, and I totally did not leave enough room. But it equals, we'll just do it right below, x plus 7 over 3 squared, right? That's what it is. Okay, so this is our inverse. Yeah, this is a function, right? This is totally a function. X plus 7 over 3 squared, that's a function, so that's true. Okay. The domain of g of x is all real numbers. When we have a square root function, remember, you can't take the square root of a negative, or you can, but it's going to be imaginary. So when we're talking functions, we're not talking anything imaginary, though. So the domain is not all real numbers, because you cannot put an x cannot be negative. X has to be, for this one, x has to be greater than or equal to 0. Okay? And now the range of g of x, well, think about with this minus 7. This is like our k is -7, so it's going to move the vertex down to -7. So if we were thinking about how this would look, say we have -7 down here, and then the square root function looks something like that. So the range is all real numbers. We're talking about our y values, and this is saying greater than or equal to 7. No, it's actually going to be greater than or equal to -7. So this is false. If it was -7, it would be true. We got to keep moving. All right. I really hope I can fit this all in. I don't know how much time I have, so I gotta hurry. All right, consider the function y equals f of x shown below. Place an x in the table to show whether each statement is true or false. The function y equals f of x is not odd because it needs to be, there needs to be rotational symmetry about the origin. Okay, so if the vertex was at the origin, then it would be true. But since it is not, I rotate my paper. Nope, doesn't look the same. So it is false. Okay, domain of y equals f of x is all real numbers. Is this graph going to hit all of my x values, everything to the left and everything to the right? If I'm thinking, yeah, it actually is. It's going to hit all x values. Okay, is it going to hit all y values? Everything down here, will all my y values be hit eventually? Will all my positive y values be hit? Yeah, they both will. This is going up forever. This is going down forever. Okay, and then the range of y equals f of x is all negative real numbers. Oh, wait a minute. So what did I just answer? The function y equals f of x has an inverse function. Yeah, this is a function, so it has an inverse function. Oh, sorry. So this is still true. Now, the range of y equals f of x is all negative real numbers. Well, yeah, it's going to be all negative, but it's also going to be all positive. So this is false because it's not just negative real numbers. Sorry, I answered this one kind of up here. I wasn't reading because I'm trying to go so fast. Okay, I think I probably got like 5 minutes left in this video, so I need to hurry. Okay, What is f of g of x? Okay, that means I am doing a composition of functions where f of x is like eating g of x. Okay, so I start with f of x, which is 2x plus 3, but instead of writing the x, I write a big parenthesis plus 3 because then I'm inserting g of x right in here. That is how we do compositions of functions, because g of x replaced the x in f of x, so it's replacing the x in my f of x function. G of x is 5x minus 1, so I throw that in there. Okay, then again, please pause, try to do this on your own. Don't just copy everything down frantically. You're not going to learn anything. Okay, I am distributing my 2. 2 times 5x, that's 10x. 2 times negative 1, that's negative 2. Then I tack on the plus 3. Got to combine my like terms. 10x plus 1 is what we get for our inverse function, or not inverse, our composition, f of g of x. Okay, now we're doing the inverse, and we're doing the inverse of g of x. And remember, g of x is just a fancy way of saying y, so I flip my x and y around. I do x equals 5y minus 1. Now I replace the y, flip my x and y around. And then I'm solving for y. Got to add 1 to both sides. That leaves me with x plus 1. Remember, you can't combine these things, so it's just x plus 1 on your left equals 5y. Because these canceled, lastly, to get y alone, I need to divide both sides by 5. Okay, I get x plus 1 over 5 equals just y. But remember, what we were solving for is our inverse of x, so it's actually just g inverse of x. If you left it at y, again, you got x plus 1 over 5. That's the key part. But knowing that, yeah, that's the inverse of g of x. Okay, last one. Again, pause. Try these before you go and watch me do them. Okay, consider the function f of x, blah, blah, blah. What is the function for the inverse of x, f of x? So again, remember, this is y. This is, well, f of x is just a fancy way of saying y, so I replace the y with x, and I'm putting the y in here now. Okay, and now I am just solving for y. First step, subtract 3 from both sides. Try this on your own. Pause if you haven't yet. X minus 3 equals, because you can't combine those, so it's just x minus 3 equals y minus 2 squared. Okay, then I have to take the square root of this in order to get this guy to go away. What I do to one side, I got to do to the other. So I get the square root of x minus 3 equals y minus 2. Okay, and then lastly, to get y alone, I need to add 2 to both sides. When I do that, I get square root of x minus 3 plus 2 equals, remember now it's just y, but what were we finding? We were finding f inverse of x, so I can replace y with that now. Okay, last one, domain now of this. Okay, think about this. Domain is all the x values you're going to hit. Well, remember, you just can't take the square root of a negative. And so pause if you haven't yet. Think about what x values are going to make this whole thing, x minus 3, be negative. And x has to be greater than or equal to 3 in order for you to not be taking the square root of a negative. So this is your domain. Whew. I got it in. We didn't run out of time. I hope you guys all have a great rest of your day.